In this video, we're going to state L'Hopital's rule a little bit more precisely. So here we are going to suppose that f and g are differentiable at all points on an open interval containing c, except possibly at c itself, and that g prime of x does not equal 0 for all x in this interval, except again, possibly at c. We're going to suppose further that the limits as x approaches c of both f and g equals 0, or now we're going to open up the possibility that they could both equal plus or minus infinity. So again, we're assuming that the limit for f and g are both 0, or they're both plus or minus infinity. In this case, we can then employ L'Hopital's rule to help us evaluate the limit of this ratio. And we will do this by taking a derivative of the top and taking a derivative of the bottom, and then attempting to take a limit once again. The nice thing about L'Hopital's rule is that it also works for left and right-handed limits only as well. One thing to keep in mind when you are using L'Hopital's rule, the more common examples of L'Hopital's rule will involve fractions, this f over g. Remember, you are differentiating the numerator and the denominator separately from one another. We are not differentiating the entire expression, so we will not be using the quotient rule. Since we have opened up the door to infinity now, this gives us our second indeterminate form, infinity over infinity. In this situation, the infinity over infinity indeterminate form is treated in the same manner as the 0 over 0 form, and we just directly apply L'Hopital's rule. We will have to be a little bit more careful in the future with our other variations, but more on that in a moment. The advantage or value of L'Hopital's rule is that usually when we differentiate the numerator and the denominator, we get a fraction that is oftentimes easier to evaluate, as the derivative tends to be a destructive process. It breaks functions down. And again, our goal here is to use L'Hopital's rule to see if we can get a real value out of this limit, or at least an infinite value out of one of these limits, and not one of these indeterminate forms. So in the next few videos, we'll take a look at more examples of employing this rule.